Good morning, students. Students, the last class we studied about what? The types of bonds, isn't it? So, there are three main types of bonds. One is what? Ionic bond. The next one, covalent bond. Third one, coordinate covalent bond, isn't it? First class we studied about ionic bonds. That is what? The bond formed between metals and non-metal is called as what? Ionic bond. Always metal lose electrons and the non-metals they what? Gain electrons. Okay, usually the atoms which has the outer shell 1 2 3 always donate electrons, and those have 4 to 7 they accept the electrons. Okay, so that what happen, which is losing the electrons they become cations, and those are gaining electrons they become anions. So they form ions, cations and anions. We know that cations are positive charge and the anions are negative charge. Opposite charge always attract each other. So there is the electrostatic force is developed. This electrostatic force of attraction only we will call it as what? Ionic bond. Like that we studied in the last class. Okay. What is the other name of the ionic bond? It can be also called as what bond? Electrovalent bond. It can be also called as electrovalent bond. Okay. Or electrostatic bond or electrovalent bond. So we studied the example, that is the formation of sodium chloride. We studied the formation of what? Sodium chloride, isn't it? Sodium lose electrons to chlorine and thus they form ionic bond between them. Okay. Today we are going to study about the properties of ionic bond. What we are going to learn? The properties of ionic bond. Okay. Based on the bond in an atom of a molecule. Based on the bond in a molecule, it can determine their properties also. Okay. The bond determines the properties of the ionic bond. Okay. So based on that, if the compounds or if the molecules, if they have ionic bond in it, what are the characteristics or what are the properties it will show? That only today we are going to show. Okay, so based on the properties, their properties based on their bond, their properties will also change. Okay, so ionic bond or whatever the type of bond, it determines the properties of a molecule or a compound. I said comparing three types of bond, which one is the strongest one? Ionic bond is the strongest one based on the three, that is ionic bond. Next one, covalent bond. Next last one what? Coordinate covalent bond. Among these three, which one is the strongest means ionic bond. The first property, since they have strong force, which force? Strong electrostatic force, that is positive and negative attraction is more. Mostly they will be found in crystalline forms. Okay, mostly they are found as crystalline solids. Okay, so they mostly they found as what solids? Crystalline solids. Mostly they are exist as crystalline solids. At the home we have common salt, sodium chloride. If you have doubt, you take that and look how it, what is the size, what is physical state. Mostly it will be exist in which form? Crystalline solids, and it has well defined shape because the molecules in the molecules the atoms are so tightly packed. The lower class itself we studied, isn't it? The properties of solid, liquid and gas. Solids, the atoms are tightly packed and they have well defined shapes. Okay, so they have well defined shapes, hence they exist in crystalline solid forms. The next one, electrical conductivity. What is this electrical conductivity? So we know that they are ions. They carry what? Ions. Crystalline solids, they have ions, but the ions are tightly packed. They cannot move. They cannot move, isn't it? They are tightly packed. They are tightly packed. For example, see, for example, here all that is crystalline solids, atoms are the ions are tightly packed and they cannot move from one place to another for the purpose of electrical conductivity. This crystalline solid, if we make it into aqueous solution, if it make it into aqueous solution, the ions are free to move. The ions are free to move and they conduct electricity. So ionic compounds, they are good in electrical conductivity when they are in aqueous solution. Aqua means what? Water, or in liquid forms. Okay, in the solid forms they never never conduct electricity because atoms, the positive and negative charges are tightly packed. They cannot move from each other. They are held together. Hence, the conductivity does not take place. So, if you dissolve the solution, if it is in solution form or it is in the molten state, that is that in aqueous solution, they are good in conducting electricity. The next one, melting point. The melting point as well as the boiling point for the ionic compounds are relatively high. We know that a lot amount of energy is needed to overcome the force of attraction between which one? The ionic bond between two atoms. So, for a bond of, if you want to cleave the bond between the two atoms, that is, if you cleave the ionic bond, we want to spend a lot amount of energy. Hence, it's the strongest bond. So, their melting point, it will lot amount of heat energy. So, the melting point as well as boiling point is relatively high when comparing to other two. When comparing other two, it was relatively high. Which one relatively high? Ionic bond's melting point is relatively high. And it is soluble in polar solvents. Polar means what? Charged particles. Okay, non-polar means non-charged particles. Polar means charged particles. Since this compound has what? Positive and negative, it should be dissolved in polar solvents. Okay, which has positive and negative. Best example is water. It is soluble in water. Water, it is split as H plus and OH minus is there. Similarly, sodium chloride, Na plus Cl minus is there. So they are good. They are easily, we can dissolve the salts or ionic compounds in water, but they are not soluble in non-polar solvents. Non-polar solvents means they does not carry any charge. For example, fat. Fat, if we take and dissolve in water, they never dissolve. But if we take the fat and put it in the non-polar solvents like benzene, carbon tetrachloride, ether, alcohol, they easily soluble because polar solvents or polar compounds only dissolve in polar solvents. Non-polar compounds dissolve in non-polar solvents. So, ionic compounds only dissolve in polar solvents. The next one, they have high density. We know salt is hard and brittle. Brittle means what? Breakable. Okay. So they are strong and they have high density as well as they are brittleness. Okay. Brittle meaning what? Easily breakable. And the reactions, they easily undergo due to the ionic bond. They are very rapid. They are very fast in their reaction. They are very fast in the reaction. They are very fast in the reaction. So what are the properties we have studied? What are the properties of ionic bond we learned? The first property is they are mostly exist in solids due to high electrostatic force. Next, they will conduct electricity not in crystal form, only in aqueous form. The ions are free to move. Next one, melting point. Due to electrostatic force, we want to apply more amount of energy to overcome the bond or to cleave the bond. Since high melting point and boiling point, they never soluble in non-polar solvents, only soluble in polar solvents. Hence, they have high density, they are hard and they are brittle. They undergo reactions very fastly. This is about the properties of which bond means ionic bond. The next one what we are going to learn is covalent bond. Next one we are going to learn is covalent bond. Three types. Second type is covalent bond, and it is formed by what? Sharing of electrons. It is formed by sharing of electron. See here, two elements are there. What are they? For example, two elements are there, A and B. Has two elements. What are they? A and B. This is the outer shell electrons. This is the outer shell electrons of A. This is the outer shell electron of B. We know that here non-metals, how they undergo ionic bond. Two processes we studied, isn't it? Transfer of electrons or sharing of electrons. Equal sharing means covalent bond. Unequal sharing means coordinate covalent bonds. So covalent bonds are formed with sharing of electrons. What type of sharing means? Equal sharing. So A is going to share one electron. A is going to share one electron. B is going to share one electron for the formation of bond, for the formation of a bond. Okay, so what is covalent bond means? It is formed by sharing of electrons, that is both the atoms share one electrons and it is common to both. And what is the other name is, it can be also called as atomic bond. It can be also called as what? Atomic bond. See here, A and B is sharing one electrons for the bond formation. So overlapping of outer shell takes place, overlapping of outer shells, the pair upping of outer shell takes place, and this is the paired electrons. Now this is common for both. For example, this is hydrogen. Okay, this is hydrogen atom, hydrogen atom. Hydrogen atom has outer shell only one electrons. We can take for example, so for example, you can take this as a hydrogen. They have only one electron. So each hydrogen shared one electrons, and this is the paired electrons, and they form the compound AB. And they form the compound AB. Okay. Here is the next example. See, I have drawn here. This is hydrogen atom. This is hydrogen atom. Outer shell one electron, one electron. Both are non-metals. Now they are going to share their outer shell electrons. See, they have shared their outer shell electrons. One from hydrogen, next one, next hydrogen. Both are sharing. Now the overlapping of outer shells takes place and they become paired. And this bond is called as what bond? Means covalent bond. It is called as what bond? Covalent bond. See, here is another one example. This is carbon. It has outer shell 4 electrons. It needs 4 more electrons to become stable, isn't it? So it is going to share all the 4 electrons with 4 different hydrogen atoms. See, my outer shell 1, 2, 3, 4. Total 6 electrons. So outer shell has 4. This 4 electrons also it is going to share with 4 hydrogen atom. So overlapping takes place at the outer shells. So one belongs to hydrogen, one belongs to carbon. Hydrogen, carbon, hydrogen, carbon, hydrogen, carbon. So that carbon achieve how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. So they now become a stable compound called as methane. Like this, these non-metals, they share their electrons among themselves. It may be shared with one atom or it may be shared with the different atoms. Anyway, they have to become a stable structure. They have to become a stable structure. See, carbon has 4 valence electrons shared with the 4 hydrogen atoms. So it forms covalent bond. It forms what bond? Covalent bond. Okay, 1, 2, 3, 4. Okay, multivalent compound. It's a multi-bond. It is an example for multi-bond formation. Okay. So these all are hydrogen that shared there because hydrogen has only one electrons. Okay, so it has shared that one electrons with the carbon so that they achieve 8 electrons in the outer shell. Now we can see the properties of covalent bond. First one, they can exist in different forms. They can because there the force of attraction is less. Hence, they can be exist in different forms. Either they can be a solid, they can be a liquid, or they can be a gas. Okay, but some exception is there. In diamond, what bond only? Covalent bond, but it exists in what? Solid forms. So it is example for the compound which exists in a solid form. Example is diamond. Liquid, water, H2O, H and oxygen non-metal. So the bond formation is covalent. Exists in liquid, oxygen gas, oxygen combines. Okay, outer side overlapping takes place. They share their electrons, so it forms a gas. So they can exist in all 3 forms. Here, as they are not losing or gaining electrons, only they are sharing. So as a result of sharing, there will be no lose or there will be no gain of electrons. Hence, there is no charged particles. They are the bird conductors of electricity. They are the bird conductors of electricity. Since they does not have cations and anions, they couldn't able to conduct electricity. The next one is melting point. Except a few compounds, for example, diamond. Diamond is very hard, and there the folds to overcome the folds we need a high melting point. Except that silicon carbide, some elements, except some elements or some compounds, remaining all they have probably they have low melting point comparing to ionic bond. Comparing to ionic bond, usually covalent bond has low melting point except one or two compounds, for example diamond. So they have low melting point. Next one, does not have charge. I already said charged compounds only dissolve in charged solvents. Non-charged compound dissolve in non. So this does not contain any what? This does not contain any ions. They does not contain any ions. Hence they soluble only in the non-polar solvents. Some of the examples you can say benzene, ether, carbon tetrachloride, alcohols, etc. Okay, benzene, ether, carbon tetrachloride, etc. So they are non-polar solvents. Okay, and some that hardness. If you see the hardness, they are either hard or brittle, not brittle. We cannot say it is so hard or it's not brittle. Okay, both the quality it was there. Okay, it was neither hard and also not brittle, but they are soft and waxy. They are soft and waxy. These compounds are either hard or brittle, but mostly the compounds are waxy and it looks soft. It looks mostly the covalent compounds are soft and waxy, and they undergo reactions slowly. They undergo reactions slowly, not like ionic bonds. They undergo the reactions very slowly. This is about the properties. So what are the properties? First, how the physical state. It can exist in all three physical forms: solid, liquid and gas. Solid example diamond, liquid water, gas oxygen gas. Since they does not have any ions, they are the bird conductors of electricity. Comparing to ionic bond, they have low melting point, but diamond, it has high melting point. Since they have no ions, they cannot dissolve in water. We cannot dissolve the covalent compounds in water. Only they are soluble. They dissolve in non-polar solvents such as benzene, ether, carbon tetrachloride, etc. And it is neither hard nor brittle, but they are mostly soft and waxy. Most of the covalent compounds in the nature, it is found as soft as well as it is waxy. Next one, they undergo the reaction very slowly. They undergo reactions very slowly. The last one, what bond means? What bond we have means covalent bond. We have what bond? Covalent bond. In covalent bond, two types is in equal sharing and unequal sharing. The last one is coordinate covalent bond. Here unequal sharing. Both the atom we studied there. Equal atom, both the atom help for sharing or pairing one electron shared by both the atom. But here both the electrons comes from one atom. For the need of bond formation, we need two electrons. Both also contributed by one of the combining atom. Then it is called coordinate covalent bond. And other name is dative bond. See here, ammonia. It has two electrons, isn't it? Okay, it is not shared by anything. Okay, this is unpaired electrons. See here, it does not have any electrons in the valence shell. Everything is filled. Everything is occupied. So now these two electrons, this ammonia is going to share with which one? See here, the two electrons for the bond formation is given by nitrogen to both, so that they form a compound. They form a compound. See here, here nitrogen, that is ammonia, it has two electrons. Okay, that is non-paired electrons. It is donated to which one? Boron trifluoride. Boron trifluoride, it does not have any electrons to share with the other. So they get two electrons from ammonium and they link and they linked to which one? Ammonia. Okay, here for the bond formation we need two electrons. Two also donated by whom? Nitrogen to boron. and they form a compound. And this is the weakest bond. Hence, both the electrons for the bond formation is donated by ammonia. It is the weakest bond. Okay, and it can also exist in solid, liquid, and gas. It has partial character like covalent compounds. Coordinate compounds does not contain charge particle, so they are the Bird conductors of electricity. Comparing to the covalent bond, they have high melting point and boiling point, but lower than ionic bond. Solubility, they are partially soluble in polar solvents like water, but they insoluble or partially soluble, we can say, in water, but they are soluble in non-polar solvents like benzene, carbon tetrachloride, ether, etc. And the reactions are very, very slow. This is about what? Coordinate covalent bonds. For the bond formation, 2 electrons are needed. These 2 electrons are contributed by only one of the atom, that is ammonia to boron trifluoride, and they form a bond. Then this type of bonds are called as coordinate covalent bond. Thank you.